sine terms. So in both the figure, what we are finding that current is leading. Current is leading. See, in the second figure, we could see Vm in the negative. That is Im. Vm is lagging by minus of 90 degree. Okay. So this is the phasors, and we could accordingly draw the current and waveform, because but the thing is that, see, in that case, in the previous figure, here it is written Vm. In the previous case, here it was written Im, because here what we could see, here we could see that current is lagging, current is leading, sorry. Here we could see that current is leading, that is Vm is Vm sine omega t, and current is leading, that is Im sine of omega t plus 90 degree. That is current is leading means current has somewhat time started earlier only. So this is the waveform which we could draw for the capacitor. Similarly, for calculating the impedance, we will be having 1 by j omega c, that is 1 by omega c minus of 90 degree. Okay, because here the j is in denominator, so 1 by omega c minus of 90 degree. Okay, so till this point, you are, am I clear?
Yes, ma'am.
Okay, so this is the question number. This question is given, that is RL series circuit is given in question number, I think, 8 or 9. You could see, and RLC series circuit is given in question number 1 itself. So this is the first question, which is related to your exercise. Okay, assignment. So in that also it is given that, so see, here we could see that R and L is present in series. First of all, if we are considering series network, in case of series network, what we could see is current through all the elements remains same. Current through all the elements remains same. That means, in case of series, voltage divides and current remains the same. So here we could clearly see that R and L is in series. Therefore, we could see that the current through R and L will be same. Therefore, since the current is same, so we could take, for easily preference, we could take current as a reference to draw the phasor. Okay, since R and L is in series, so current is same through both the elements. Since current is same, so we could take current as reference to draw the phasor. If we are taking current as a reference, that means we are representing it in time domain, that is it is equal to Im sine omega t, or current in terms of phasor, that will be equal to I bar is equal to Im angle 0 degree. Am I correct?
Yes, ma'am.
Okay, similarly, since I am saying that current is same, because R and L is present in series, so voltage across R, now what I am doing, I am considering voltage across R as VR and voltage across L as VL. Because voltage, I don't know what it would be, but current, I know current is same. So current is taken as reference, and for the resistor, some voltage is considered, and for the inductor, some voltage is capacitor. We need to find out what is VR. That is VR, that is voltage of resistance in terms of phasor, VR bar. Similarly, VL bar means voltage of inductor with phasor of voltage of inductor. Okay, so it will be VR bar is equal to R into I bar. I bar we have already calculated, that was Im angle 0 degree. That is V of bar is equal to R into Im angle 0 degree. Similarly, V of L, that is phasor of inductor voltage, that is equal to I bar into ZL. So here what we could see, in case of inductor, the impedance is j omega L. We already have calculated it earlier. So V of L is equal to I bar is Im angle 0 and ZL is j omega L. Im is having 0 degree and since it is j omega L is in multiplication form, so j is having an angle of 90 degree. So when we will be adding 0 degree plus 90 degree, we will subsequently get VL bar is equal to Im omega L angle of 90 degree. Okay, so we have calculated voltage of resistance in terms of phasor and voltage of inductor in terms of phasor. Since we have calculated, so what we need to, we have to apply KVL. If since this is the loop, since this is the loop, and if we